Imagine sending a message across the vastness of space, from Earth to a colony on Mars, and knowing it's perfectly secure, impossible to intercept or decipher. This isn't the plot of a science fiction movie. It's the promise of the quantum internet, a revolutionary technology set to redefine how we communicate across cosmic distances. Unlike the classical internet that uses bits, which can be either a 0 or a 1, the quantum internet uses qubits. Thanks to a principle called superposition, a qubit can be a 0, a 1, or both at the same time, allowing it to carry vastly more information. But the real magic lies in a phenomenon Albert Einstein famously called spooky action at a distance. This is quantum entanglement. When two particles, like photons of light, become entangled, they are intrinsically linked. Whatever happens to one instantly affects the other, no matter how far apart they are. If you measure the state of one entangled particle, you instantly know the state of its partner, even if it's millions of kilometers away on another planet. This instantaneous connection is the backbone of the future quantum internet for space. Current space communication relies on radio waves, which are vulnerable. They can be jammed, intercepted, and the signal weakens over long distances, requiring massive antennas and powerful transmitters. The farther we venture into space, the less reliable this method becomes. A message to Mars can take up to 20 minutes one way, and the data transfer rates are incredibly slow compared to what we have on Earth. This communication lag poses significant risks for astronauts and the operation of robotic missions. This is where the quantum internet changes the game. By using entangled photons, we can create communication channels that are, by the laws of physics, unhackable. Any attempt to eavesdrop on an entangled signal would disturb the system and collapse the quantum state, immediately alerting the sender and receiver. This process is known as quantum key distribution, or QKD. It allows two parties in space to generate a secret key made of entangled particles. This key is then used to encrypt and decrypt classical data, ensuring that even if the classical data is intercepted, it's just meaningless noise without the quantum key. Scientists are already making incredible progress. In 2017, a Chinese satellite named Metis successfully sent entangled photons to two ground stations separated by over 1,200 kilometers. This experiment demonstrated that quantum entanglement can be maintained over vast distances, paving the way for a global and eventually interplanetary quantum network. The European Space Agency is also exploring quantum communication with projects aiming to establish secure links between Earth and satellites. The number of challenges is significant, of course. Maintaining the delicate state of entanglement, known as coherence, is incredibly difficult. Quantum states are fragile and can be easily disrupted by environmental noise. Researchers are developing technologies like quantum repeaters. These devices would act as nodes in the network, taking a fragile quantum signal, purifying it, and then retransmitting it without destroying the original information, effectively extending the range of the quantum internet across the solar system. Imagine a network of satellites and ground stations on Earth, the Moon, and Mars, all connected by a web of entanglement. This would enable real-time, high-definition video calls with astronauts, instant control of rovers exploring distant moons, and the secure transmission of massive amounts of scientific data. This technology won't just benefit space exploration. The principles developed for space-based quantum communication will also enhance our terrestrial internet, leading to ultra-secure financial transactions, private communications, and new possibilities for distributed quantum computing. We are standing at the dawn of a new era in communication. The quantum internet will not only be an upgrade, it will be a complete paradigm shift, weaving the very fabric of space-time into our information network and connecting humanity across the stars in a way we've only dreamed of. For more deep dives into the future of space technology, make sure to follow and subscribe to Space Repo.